All right, today's plan just to go over, I think I got 2 or 3 more of these examples, and then we can get into the homework and ask questions about that. And then once that's done, I'll set you free to continue working on that homework. Some of these questions can be problematic because they don't give you direct measurements. You have to use, you might be using stuff from chapter 1 and chapter 2, chapter 3 to find some measurements that you need to use inside your proportions. That's exactly what's happening in this question. I want to ask to find X Y and Z in this problem. So if we look at those, would you guys agree, or can you tell me what type of segment that is there, what GE is for the entire right triangle? It's a leg. So the leg should be a geometric mean, correct? Should go there and there. Now, it should go between what 2 values then? Good. The hypotenuse, which would be that distance there, correct? So I'm going to put 16 in that spot. And now the part of the hypotenuse that is touching the leg. How big is that GH? It's got to be 4. Okay, so there we're using, that's what I was saying at the beginning, that's not a direct value provided. You have to use the segment addition postulate there to find X. So X squared then, when I cross multiply, actually let's save the multiplication once we get all of these completed, all these proportions set up. Okay, so that segment there is the what? That's the altitude. And we were calling that yesterday the interior altitude, okay? Because X was an altitude as well, right? Okay. But it's the interior altitude, so that goes there and there. Now between what 2 values then? Four and 12. So that interior altitude should be the geometric mean between that green segment and that segment. But the corollary says that the altitude that is drawn from the right angle to the hypotenuse is the geometric mean between the 2 portions of the hypotenuse that altitude generates when it intersects right there at H. So we'll put 4 here and 12 there. Can you flip-flop those? Yeah. Okay, so it doesn't matter which one's 12 and which one's 4. And then the last one, Z. Would you agree that this is another leg? Okay, so that's going to be the geometric mean between the hypotenuse and a part of the hypotenuse that is attached to Z. Are we okay with setting them up like that? All right, so let's go through then and do the algebra. This one here, what kind of number is 16? Perfect square. What kind of number is 4? Perfect square. So I'm going to leave this as, when I go x squared, when I cross multiply here, I'm going to leave this as just 16 times 4. Okay? Just try to prove a point here. I'm foreshadowing. I'm always thinking 2, 3, 4 steps ahead to allow me to maybe save myself some time. If I square root this, I can square root that side. Does that make sense? And that's going to give me x equals the square root of 16 times 4. But we talked about yesterday, the square root of a product is equivalent to the product of square roots. So I can actually separate those. And the reason I would do that is now because what's the square root of 16? 4, what's the square root of 4? 2. And my hope is that eventually you can go from like this straight to this because you recognize that both those were perfect squares. You square root the 16 in your head, square root the 4 in your head, and multiply their results. Okay? If you're not able to do that, and you just say, okay, I'm not going to foreshadow, I'm going to go x squared, 16 times 4 gives me 64, square root both sides. That's going to lead to x equals, what's square root of 64? Still 8. Okay? So either route will work. It's not a big deal going this route here because 16 times 4 is that's not a huge quotient. But sometimes you'll get numbers that are very big and that you multiply them through, and then the square rooting process undoes that. So it seems that that first multiplication is kind of a useless step if you're worried about taking up time. I see that again in this question, this next one. But let's just go ahead and go y times y gives you y squared. Let's write that as 48. Okay. Square root both sides. Give me radical 48. Now, there should be plus or minus. They should have done that with the 8 up here as well. But because I'm interested in it being a distance, I'm ignoring the minus one. But that 48, does anybody know the perfect square that divides 48? Okay, so 4 radical 3 is the result, which means that that 4 came from what number? Would have came from 16. So 16 is the largest perfect square that will divide 48. So 48 can be rewritten as 16 times 3. And radical 48 can be written as radical 16 times radical 3. So radical 16 then is 4, and I got my radical 3. That's an approach. If you don't like that approach, that's fine. If you're more of a person that says, I got to take 48, break it to 2 and 24, 2 and 12, 2 and 6, take 6 down to 2 and 3, and say, okay, there's a group of 2s, and there's a second group of 2s. So this group can come out, the green group can come out, the blue group can come out, and then this 3 that doesn't have anything stays underneath. Does that still turn into 4 radical 3? Okay. I'm a fan of doing it this way. So I go, what? Because we've seen, and this is another thing about mathematics, we've already done radical 12. We did radical 12 yesterday several times in previous problems. Okay. So I already know from memory that radical 12 is 2 radical 3. Does that make sense? Okay, it's like knowing that 1/2 is the same thing as 2/4. And every time I see 2/4, rewrite it as 1/2. I know from memory that that's 2 radical 3. And I know that that is 2, right? So what's 2 times 2 radical 3? 4 radical 3. And that might be a reason why I don't change that to 48 when I do that cross multiply. Anybody know what, off the top of their head, real quick, what 16 times 12 is? Say again? If you type in it, so that's my argument on why, again, I don't like doing this multiplication. I know I'm going to radical it. I'm going to square root it. So that's going to undo some of this multiplication. What kind of number is 16, though? Perfect square. So I know that when I square root, I'm going to get something like that. And I know square root of 16 is 4. Did we already do square root of 12? Square root of 12 over here was 2 radical 3, wasn't it? And if I didn't know, if I didn't commit that from memory, isn't it easier to take 12 and go 2 and 6, 2 and 3, and rewrite that as 2 radical 3 than it is to take 16 times 12, which is, what is that, 196? 198? 192? I'll say I can't do it. So 4 times 2 then is 8 radical 3. And that, I think that's more efficient, easier than saying, okay, 16 times 12 is 192, and then taking the 192 and doing the factor tree with it to where you end up getting 8 and 3. Does that make sense? Or 8 radical 3. Okay. We'll scroll down here. This is the last one I want to do from the notes. Gets a lot more difficult, okay? And what I want you guys to, and it's probably due to the way that some of these questions have been designed so far, but they've been designed in the way that they have been so that we understand what we're doing and we understand the procedure of how to set up the proportions. But the way they've been designed is that every single variable we solve for has been a geometric mean. That doesn't have to be the case. Remember, the geometric means in our proportions are not the variables, but they are those three segments. Does that make sense? Those are the things that need to be geometric means. So if I look at the first one here, look at that leg, we should put y in the geometric mean position. Now, what is the entire hypotenuse then? Oh. So the entire hypotenuse is this x. And now what part of the hypotenuse touches y? 6. Okay? This is a perfect example of why I never solve my proportions immediately after I create them. Because if I do here, can I solve for x or y? I get 6x equals y squared. That's a nonlinear equation of two variables, and I would need another equation with the same two variables. So I'm going to go and look at this here. That's my other geometric mean. So this is where it's a little bit different than the problems we've done, because now in this next ratio, 8 goes in the geometric mean position. Okay. Now, it should be the geometric mean between that distance and that distance. So what is that purple distance? 6. What is the blue distance? X minus 6. You have to use the segment addition postulate there. And then finding Z, which is the leg. So Z is the leg, so that's the geometric mean. Now between the hypotenuse, so X, right? And now what is the part of the hypotenuse that is touching Z? X minus 6. Say it again. Yeah, but the way it's phrased, it's the part of the hypotenuse that is touching the leg. This is touching that leg down here at this corner, right? But it's not. But Y is not part of the hypotenuse. Does that make sense? So when you do this, guys, there's a whole lot of different approaches that people come across. They say, okay, I'm just going to go ahead and write y squared equals 6x. They go 64 equals 6x minus 36. Just cross multiplying these, right? Make sure you distribute. And then here they go z squared equals x squared minus 6x. Okay, which one of those is the only one that I can solve for a variable? The second one. Okay, so I'm going to solve that one. And so I'm going to add 36, so it's going to give me 100 equals 6x. So what, 50 over 3 will equal x. Okay. Now that I've got x, we have options. We can go through and say, okay, I'm going to plug it into there and solve for y. Or if you haven't multiplied these out yet, you could actually just say, put it back in the proportion and now cross multiply there. Does that make sense? But regardless, you're going to multiply 50 thirds times 6. So I take 50 thirds times 6. That's going to give me 100. So, I mean, I'm doing what we just did here, basically. So I got y squared then is equal to 100. So what is y going to be? Take the square root. You divide it by 2. Remember, we're trying when we go when we do radicals, it's what number multiplies 2 times to give that 100. It's got to be 10, right? Okay, so y is 10. X was 50 thirds. Come down here. You can put 50 thirds in here again. Put it in there again, depending on how you want to do it. I'm just going to put 50 thirds over here. So z squared 50 thirds squared minus 6 times 50 thirds. Okay, 50 thirds. So how do I square a fraction? Anybody know? Just with mental math, how would I do squaring a fraction? Yeah, doesn't 50 thirds squared mean that? And if I wanted to do that multiplication, I go straight across the top, so that would be 50 squared. Straight across the bottom would be 3 squared. So how do I go from this here to this here? Is I just square the top, square the bottom, right? So 50 squared is 2,500. And then 3 squared is 9. This will give me, so 6 times 5 is 30. So it's going to be minus 300 over 3. How do I subtract fractions? Common denominator. So you multiply that by 3, multiply that by 3. So I've really got 2,500 over 9 minus 900 over 9. So it's going to give me, what, 1,400 over 9? That kind of makes sense. Now, what is that? What does that equal to? So far, that's my z squared, isn't it? Okay, so what do I have to do with that to find z? Square root. That turns into radical 1,400 over radical 9, right? Does anybody know two numbers that multiply together give me 1,400? 1,400. Doesn't 14 times 100 give me 1,400? Now, the reason I break it that way is because I know 14 is 2 times 7, right? So there's no perfect square that divides 14. And 100 is a perfect square, right? What's the square root of 100? 10. So 10 radical 14 and radical 9 is 3. So there's my z value. And here's the thing. I mean, there's a lot of algebra there, right? Okay. Lots of algebra that is going to confirm. So if I gave you this problem, and I'm going to judge the geometry, I'm going to judge whether you could create those three things. My argument is that most of us probably create those three things with 100% accuracy. But are we all going to get that number that was what I'm going to use to base whether those three proportions were accurate? Does that make sense? Okay. I always make the comparison to my students, and I've probably said it in here before. You guys know what area is? You guys know what slope is? You've heard that calculus is very difficult. I just taught you calculus. It's area and slopes. But calculus is very difficult. It's very hard. And it's very hard because the algebra that is inside finding those areas and finding those slopes it's tedious, okay? And as Algebra 1 students, as a 9th grader or 8th grader, we don't maybe realize the necessity of algebra. How's it going to play out? Algebra is the car that or the engine that drives the mathematics car. Without algebra, none of our other mathematics makes sense or works. Okay, so we need to make sure that we're very, very in tune with our algebra. Questions on the homework? Specific numbers you want to go over? 15? All right, so I want you to find x here, okay? So I need to go through and figure out how do these three parts that they give us relate to one another, okay? So I'm looking at this overall triangle, okay? That's a right triangle, and I'm going to look at, let's just call this item 1. Actually, let's do it this way. What part of this, if we label this as A, B, C, which segment is the hypotenuse? BC, right? Okay. That means that this is a leg and that's a leg, right? Okay. Obviously, there's nothing over here for AB for me to use. There's nothing on this altitude here on the interior to use as a geometric mean. So it's this leg that we have to use as the geometric mean. Is that okay? All right. So then what goes here? What goes in this top 11 plus x, I think, is the best thing that can go there. Okay, because it's the whole hypotenuse, right? And now, what should go here? X. Okay, so it's the leg is the geometric mean between the whole hypotenuse and then the part of the hypotenuse that is adjacent to or touching the leg that was being used as the geometric mean. That's the geometry. If you can get there, you've mastered the geometry. That was our overall goal. Okay. But from there, we have to cross multiply, right? Okay, if you remember from section 7.1, I gave you a worksheet that had, I think it had like 10 questions on it at the top. You had to do 6 of them that were proportions like this. That forced you to get a situation where you have to factor, okay? The purpose of that was because you're going to see that type of algebra in this geometry later on in the chapter. So I cross multiply, I have to FOIL those, right? So it gives us x squared plus 10x plus 25. Cross multiplying here, we get 11x plus x squared. And we've lucked out. Okay, why have we lucked out in this problem if I write the equation like that? It started to look pretty nasty with the x squared, didn't it? But there's one on each side, so they cancel each other out. So that x squared and that x squared can be subtracted away. You're left with now 10x plus 25 equals 11x. $25 then ends up being x. Let's do something here real quick. Now that we know x is 25, could we figure out what this distance right here is? Can I call that, let's just call that y. Could I say that y is the geometric mean between 11 and 25? That makes sense? Makes sense. So can I then say that y squared equals 25 times 11? So y will then be, if I square root both those, 5 radical 11. Is that okay? So that will be y. Let me ask you this, though. Do we have another way of doing that? Now, I haven't taught this to you. I think it's section 8.1 or 8.2, so we haven't gotten there yet. But what kind of triangle is this right here in red? Right triangle, right? What's the number one theorem or even formula that you guys have ever used with right triangles in your math careers? Starts with a P. Yeah, you've used the Pythagorean theorem, right? Okay. You've used a squared plus b squared equals c squared, right? Where a and b are your legs, correct? Okay, so we just said one of our legs was 25. So I'm going to say a was 25. My other leg b is this distance here of y that I'm looking for, so let's call it y squared. And c is the hypotenuse. So x was 25. That should be now 30, right? So I'll say 30 squared. Okay. So 25 times 25. Anybody know what 25 times 25 is? 625. Plus y squared equals, what's 30 times 30? 900. Okay. So now I get y squared equals 900 minus 625. What's 900 minus 625? Okay. Is 275. Let's think, if I square root this, let's go to 275. Since it ends in 5, it's divisible by 5, right? So 5 goes into 100. How many times does 5 go into 100? 20. So then this would be, so it's going to go in 40 times, and then how many times does 5 go into 75? 15. So 5 times 55 will give me 275. Does that make sense? What divides 55? 5 and 11, right? Is that a group of 5s? Come out. And then we got our 11 that stays underneath. So what I'm trying to show you here is this proportion process with geometric means is a valid concept because we were able to find the exact same answer in this situation for that y distance by using another concept that we've already demonstrated or already learned to be true. Okay, so a squared plus b squared equals c squared is different than this geometric means work. Yes. The quadratic formula. So that quadratic formula. So that will factor. So if I had something like x squared, let's go plus 5x plus 6 equals 0. My hope is that we know that factors to x plus 2 and x plus 3 equals 0. So x will equal negative 2 and x will equal negative 3. If we didn't know that, though, that number 1 right there is what we call A, that 5 is B, and that 6 is C. If we were to take those numbers, those coefficients, and plug them into that, it's going to spit back negative 2 and negative 3 after we simplify. So that's what the quadratic formula does for us. Does that help with question 15, though? Anything else you guys want to talk about? Any specific problems on there? All right with the rest of them? All right, that's all. If that's the case, that's all I've got for you today. You can use the remaining time to complete that assignment. Okay, you've got plenty of time, about 20 minutes here. Then you can put a pretty big dent in that. And if you come to questions as you work on it, let me know. And I don't mind if you're working with one another.